Hey everybody, this is Alex Merced, and you're listening to another episode of Gnarly Dataways presented by Dremio. And today what we're going to talk about is Dremio and data lakehouse table formats. So this is things like Apache Iceberg, Delta Lake, Apache Hudi, and just sort of how they relate to Dremio. Because at the end of the day, Dremio is the open lakehouse platform. So regardless of what tools you're using, what data formats you're using, where you store your data, Dremio tries to have a story for you to be able to work with your data on the Dremio platform. Now, why not try the Dremio platform? So if you haven't tried it yet, go give it a shot. You can head over to dremio.com and try the Dremiotestdrive. There's no cost, no obligation. Just gives you a chance to kind of get hands on, try out a few queries, and yeah, get the feel for working with the Dremio Lakehouse and what it can do for you. And make sure you get an early copy of Apache Iceberg Definitive Guide. So again, right there, you can scan that QR code and get the first couple chapters so you can learn more about Apache Iceberg in this new O'Reilly book coming out early next year, where you can get yourself an early release copy by scanning that QR code. We got plenty of episodes of Gnarly Data Waves coming up in the coming weeks. So next week we'll be talking about getting started with Dremio data reflections, learning about the secret sauce of Dremio. After that, we're going to talk about simplifying data mesh with Dremio's Open Data Lakehouse. After that will be best practices for building a data lakehouse on ADLS, so that's on Azure. Okay, and then versioning data in the data lakehouse. We're going to talk about the differences between file, table, catalog versioning. So make sure not to miss any of these great episodes every Tuesday, same bad place, same bad time. Okay, and also just be aware that Dremio is doing these events with AWS and Tableau in Chicago, New York, Toronto. So if you're going to be in any of these places on any of these dates, make sure to come pay us a visit to these really cool events, along with events all around the world, such as Big Data and AI World, Data Festival, Coalesce, Big Data London, Big Data and AI. Dremio will be everywhere. So if you're at any of these events, come make sure to visit the Dremio table, pick up some swag, say hi, and have some great conversations. But with no further ado, let's get started with our feature presentation. We're going to be talking about Dremio again and data lakehouse table formats. I will be your chaperone this evening as we go through this exciting and interesting topic, because table formats are a big deal for good reason right now. Okay, so let's just kind of set the stage first. So we're going to do an overview of those three formats and kind of talk about how they work and what they are. But let's just set the stage for why they are needed, the world that we're in today. Okay, so essentially what's happening when it comes to very large scale data, big data, the quickness of that data grows and the ways we want to use it is expanding. It's just basically growing so fast that no one tool can really add all the features fast enough that you would want to do every workload that you want. So the old days of just saying, hey, I'm going to have a platform, so this is my data warehouse, and I'm going to do everything through that data warehouse, it's just becoming harder because, again, no particular platform can be everything fast enough. Okay, so you need access to multiple tools. And generally, like the best place to have for those tools to have access to that data is going to be on your data lake. So that way it's stored in one place, and then all your tools can then access that one place. Okay, so to deal with sort of that technological expansion, you have the data lakehouse pattern. Okay, the idea of, store the data in one place, and then all your tools externally access that data. Okay, and then do these kind of data warehouse like workloads. Okay, so the difference is, like before, data lakes were like more read-only. A data lakehouse, because of some of the components we're going to discuss, you go beyond just read-only into like being able to do full-on updates, deletes, and much more a variety of types of workloads on the data lake with much better performance. But the other thing I want to point out is just like the scale also has a secondary issue. So there's the technological issue that data lakehouses solve, and then there is the cultural issue, which is, hey, there's just so much data that our centralized IT team, they just can't scale up necessarily like their knowledge of the context of this data and organize and curate this data fast enough to deal with that sort of, now huge scale. Okay, so this is where like the data mesh pattern comes in, where you break up the division of labor for who's working on the data into teams based on, domain expertise, subject matter experts, stuff like that. So that way you have different teams that can focus on producing data products quickly. So both of these are part of the picture of dealing with scale today, the technological picture and the cultural picture. We'll talk about data mesh a little bit more in a couple of weeks, but just trying to kind of give you that sort of big picture. Where is the industry going? Why are we going in that direction? It's not just because, it's a shiny buzzword there's genuine problems that are being fixed here, again, of technological and cultural scale. Okay, but the key piece on that technological scale issue is to be able to do those data warehouse-like workloads on your data lake. Okay, and for that to happen, you need like a data warehouse. When you think about it, it's just like a box, and there's a lot of stuff going on in that box that is abstracted away from you. One of those is just sort of like how is the data stored and how it understands the data it's stored. So basically there's a way that that data warehouse stores data. Okay, in the data lake world, we're going to think Parquet files, but there's also going to be a bunch of metadata that data warehouse is going to store in order to be able to scan that data more efficiently. Okay, so in this case, we need metadata to help us scan through all these Parquet files more quickly. Not only do that, but also be able to just think about them in a more intuitive way. Instead of thinking about it as, hey, these 1,000 Parquet files represent data set A, I just want to think table A. Okay, and I just want to run a query in table A and not think through, all the underlying stuff. I just want to say, hey, I just want to scan table A and run this where clause and get me that data. Okay, and this is kind of what table formats bring you. Okay, they're going to give you the ability to sit there and say, hey, there's table A on my data lake, there's table B on my data lake, and also allow more efficient query planning because of the metadata they provide. Okay, and there's going to be generally 3 main formats that kind of fill this role. They do have their differences, but all of them are constantly adding new features. So a lot of things that made them like different as far as feature sets, I would say are less so nowadays. And again, they're constantly getting closer and closer to feature parity. Again, there's going to be different use cases for different aspects of them, or different ways that they're executed and different ergonomics. But at the end of the day, like they generally serve the same promise. Where there is some more variance is going to oftentimes just be in sort of like what tools know how to read them. Okay, and again, comes back to that whole technological scale issue, being able to have access to many tools as possible. Okay, but let's go over those 3 formats. Okay, the first format's Apache Iceberg. Okay, so now Apache Iceberg's approach is it takes a look at your data as a sequence of snapshots. Okay, and each snapshot, okay, is made up of a manifest list. Okay, so these manifest list files in this metadata tree that Iceberg maintains. Okay, so everything is done through this metadata tree. Every snapshot is a manifest list. Okay, and each manifest list is literally a list of manifests, which are groups of files that make up that could be part of a snapshot. So that same manifest could be parts of multiple snapshots. Okay, so this is one of the nice things about this design. You have reusability of these manifests to help optimize the amount of storage you do in trying to store all this metadata. Okay, instead of creating replicative lists when you don't need to. Okay, but every time you make a change to the table, you need to capture sort of the new definition of the table, and that's what this metadata file is. Okay, there's always sort of a newest or root metadata file that represents sort of the table as it is. It has a list of the schema of the table in previous schemas. It has a list of the current partitioning scheme of the table and any previous partitioning schemes. It has the list of snapshots and previous snapshots, so that way an engine can get there. But how does an engine know which is the current or root metadata file, the one that sort of is the end-all source of truth? Okay, the way it does that is through a catalog. Okay, and the catalog basically is going to be a list of tables with a reference to whatever their current metadata file is. So that way there is no question what is sort of that root metadata file, what is that source of truth metadata file. Okay, so a query engine looking to read an Iceberg table would basically consult this catalog mechanism, which could be a variety of things like a Hive, there's Nessie, there is JDBC, AWS Glue, the REST catalog, DynamoDB catalog. There's a variety of mechanisms you can use to be this catalog, this arbiter of which tables exist. Okay, so the engine would then consult the catalog, learn which is the newest metadata file, figure out which snapshot it wants to scan the manifest for that snapshot, where it's going to see the groups, the manifests, which will have metadata stats, and it can then do partition pruning based on those metadata stats and say, okay, hey, well, these manifests have nothing to do with my current query. So we're not even getting rid of individual files, we're just getting rid of big chunks of files. And then once it realizes, okay, hey, only this handful of manifests are related to this query, those manifests have the list of the individual files with stats on those files, so you can do further pruning. Okay, so that way when you actually do your query plan, you're only scanning the files that are absolutely necessary. So you're doing a high level of data skipping. Okay, you're skipping data files that don't need to be scanned because of that, how that metadata is laid out and how the engine can use it. Okay, and then your engine would just go scan the metadata based on how that engine scans the data based on how that engine scans the data. Okay, the benefit of these table formats again is going to be in having that more efficient query plan on the onset. Okay, and also the snapshot isolation that all three of them provide, so that way you can do things like time travel. Okay, but again, everything in Apache Iceberg, you have your metadata files that capture sort of the definition of the table as a whole, your manifest lists, which capture a snapshot of the table, and then you have manifest, which captures a group of files. Okay, and then that's basically how you capture the information about the table. And basically, you have this metadata tree that allows engines to be able to discover, hey, this is the table, these are the files I need to scan. Okay, then there's Apache Hudi. So Apache Iceberg was created at Netflix to solve issues that they were having with Hive. Okay, Apache Hudi was created at Uber, particularly to handle sort of large amounts of streaming data. Okay, so it's very designed, and you can really tell from a lot of the design that like it really has like sort of a streaming first mentality. Okay, because everything is sort of tracked through a timeline. So instead of having like individual snapshots, you have lots of events. Okay, and then there's different categories of events, whether they're inserts or optimizations and whatnot. And essentially, every time there's a commit, it captures sort of what type of event it is, what timestamp the event occurred at, and basically based on that timeline, you can then reconstruct the table. So if I scan the table at X, it would then just traverse all the events in the timeline to reconstruct the table at that point. Okay, so the idea is, and again, depending on the query query, it'll know, hey, which events should I listen to, not listen to, whatnot. But it's very geared for streaming. Where you're just capturing just the basic event, so that way you're not necessarily writing a bunch of other data that's about what happened. Okay, so you can do it really quickly for that sort of real-time nature of data. Okay, it still is you'll see that Apache Hudi and Delta Lake still take a very directory-based structure to the physical layout of the table. So that means that like old Hive tables, the way the table works is all the Parquet files would be in one folder, and then all the partitions would be separated into subfolders. Okay. Okay, and then that's just how Hudi and Delta Lake work. Apache Iceberg, because of its metadata structure, that's not necessarily a requirement, but it is what it is. Okay, and again, remember I mentioned data skipping. So like in Apache Iceberg, you had those chains of metadata, and each of them had information to skip data. Apache Hudi has a separate metadata table that includes the column and file statistics, so that way you can kind of do that same thing where you skip certain data depending on what your query is. Okay, so that's going to be where their data skipping mechanism is. It's going to be again in that metadata table. Okay, which is now I'm pretty sure now it's by default it's active on any table you want. You can't turn it off if you don't need it, but now I think it's on by default. Okay, now Delta Lake. Okay, Delta Lake was created by Databricks. Okay, and when Databricks is building their data lakehouse platform, okay, they needed a way to be able to run analytics on the data lakehouse faster. Okay, because again, you don't just Parquet files are pretty efficient, right? Because Parquet files have like row groups and they have metadata on these row groups, so that way you can say, hey, I don't need to scan this row group, I don't need to scan this row group. But when you have like 1,000 Parquet files you need to scan, it's even if you don't scan any row groups, it's still inefficient to open up the file, read the file. And this is what these table formats do. They allow you to skip files. So Databricks created Delta Lakes to allow its platform to be able to skip files to scan more efficiently when you're using the Databricks platform. Okay, and eventually they open sourced it so that way other people could build data lake functionality into their tools, or Delta Lake functionality into their tools. Now, the way Delta Lake works, it's very similar to like Git diffs. So if you've ever seen like use Git for like code, a Git commit's really like, okay, hey, we added these lines of code and we subtracted these lines of code. So each commit, okay, so each of these commit files, or aka Delta log file in Delta Lake, what it does, it captures, okay, these files were added to the state of the table, these files were removed from the state of the table. Okay, and essentially the engine would just start from the first commit up into the current commit that represents the state of the table that you're scanning, and then recreate, okay, these are the files that are making up the table. Okay, and then there's generally a separate index that'll help with the data skipping. Okay, it'll maintain indexes on the different columns that represent the different files. Okay, but there's also these checkpoint files. So what will happen is that, let's say you have 5 commits, it can be, it can be time consuming for an engine to go through every single commit and reconstruct that table. So what they allow you to do is say, okay, hey, up to this commit, because I'm really going to be scanning typically after this commit. Okay, so let's just create a checkpoint that summarizes, let's say, the 30 commits up to that point. Okay, so that way, instead of having to go through 30 commits to construct your table, you have this summary file, this checkpoint file that allows you to kind of start in at a quicker spot. Okay, so that's sort of like the architecture of Delta Lake. Okay, also again, that physical structure is generally one folder with all the subfolders that are partitions. Okay, and essentially you have, again, the Delta logs, and you have the checkpoint files. Okay, and again, in these files, you have indexes of the columns to help capture information about those files to then, do data skipping. Okay, so the recap, the metadata in Iceberg is throughout that metadata tree. In Hudi, it's in that separate metadata table, and in Delta Lake, basically in each of these commits, they're also tracking indexes on as each of these files get added. Okay, so that gives you an idea. At the end of the day, like, all 3 of these are going to allow you the ability to time travel because they're capturing different states of the table. They're all going to enable ACID transactions. Okay, they're all going to allow you to update the schema of the table, so schema evolution. Okay, basically, again, some of the bigger distinctions you'll see in practice are going to be sometimes just their performance with a particular engine. Okay, and this is, I think, a mistake a lot of people make where they ask themselves, like, hey, which format is more performant? Okay, because each format is essentially a standard way of organizing a table. But what's going to determine how performant reading that format is going to depend on the implementation in the particular engine. So you could use, 2 different query engines on the same format and get 2 very different performances. And some might be better on different engines because it's going to be based on how the reading of that format is based in that engine. So, and also depends on the query, the settings of the individual table, because each of these formats have a lot of configurations you can put on how the table works, and that can vary between engines. So there's a lot of aspects that if you really want, if performance is your biggest consideration, it's really hard to truly avoid just actually running your own internal tests based on workloads that you typically run. Okay, so I just want to kind of come out with that because you see a lot of benchmarks out there, but the problem is, like, it's a lot of it relies on the particular engine implementation. So it's just saying, hey, like, if basically a plain vanilla table performs this way on a data set that isn't represent your particular workloads, isn't going to give you like the best approximation for you to evaluate. So you do need to kind of run those when you're evaluating these if performance is sort of one of your key priorities, because you can get wildly different results depending on sort of what your workloads are, what tools you're using, etc. Because again, each tool, while they can use a lot of the shared libraries in these open source projects, there are aspects of that implementation that are engine specific that are going to have engine specific considerations. Okay, but today we're going to be focusing on talking about Dremio, because we're going to talk about what Dremio provides when it comes to each of these formats. Okay, now Dremio, you're probably aware of that Dremio is going to have sort of the most robust support when it comes to Apache Iceberg, because Dremio is built really top to bottom with a lot of Iceberg-esque flair. And we'll go through that as we mean. But first, let's talk about what happens when you have Iceberg tables on your data lake and how Dremio makes using Apache Iceberg on your data lake and data lakehouse very easy. Okay, it's really like having being able to have your data. Basically, the difference between like a data lake and a data lakehouse is just really, once you take those Parquet files and you make them a Iceberg table, you now increase those possibilities with ACID transactions, time travel, things that were only like data warehouse kind of features before. So right there, it's the table format that really crosses that line into data lakehouse. Okay, but with Dremio, it tries to give you a full suite of SQL that you can run right out of the box on your Apache Iceberg tables. All you have to do is connect the catalog, which could be, you can connect an S3 bucket, you can connect an AWS Glue catalog, you can use a Nessie catalog, or like Dremio provides Nessie catalogs as a service. It's called DremioArctic. I'll talk more about that later on. But basically, you just connect one of these and you can begin running SQL like you had a database connected. Okay, so that means you can create tables, alter tables. You can use this copy into command that actually makes taking JSON and CSV files and just adding them into an Iceberg table much easier. It basically just takes all the records in your JSON file or your CSV file and then just adds them to the Iceberg table without a bunch of intermediate steps. So that makes it a lot easier. Eventually, that command will support Parquet files, so that we can just say, hey, here's these Parquet files, add their data to this Iceberg table. But bottom line is like Dremio is really constantly adding these commands that kind of just help make it easier to work with Apache Iceberg. Okay, you got full-on DML, so you can insert records, delete records, update records, run merge into statements, all from the Dremio UI. Okay, again, just the idea is just you don't really have to think about all the nooks and crannies with Iceberg with the Dremio platform. You just literally connect the catalog. Again, you could just literally connect your S3 after signing up for DremioCloud in like 2 minutes and run create table statements, and you've now created Iceberg tables. Okay, it makes that whole process very easy. And then you can run queries and it'll take advantage of the Apache Iceberg format for partitioning. So basically, it will take advantage of all that metadata at a very granular level, okay, to give you those best query plans, okay? And even now, another issue when it comes to all three of these formats is the issue of optimization, because now you have these data lakehouse tables. But again, another thing that's happening in a data warehouse that you don't realize in that abstraction is that not only is it storing and managing managing metadata, but it's also optimizing the metadata. It's also optimizing the physical holding of those files as you add more data. And oftentimes you just don't think about this because this is all included in sort of what the data warehouse is doing for you under the hood. Okay. And again, this is not about whether you use a data warehouse or not. This is about the issue again. There's just no platform that's going to be the end all be all. So you want your data in a format that's going to give you access to these tools. Okay, so having your data in Apache Iceberg allows you to have your data in a format that many data warehouses can use and many data lakehouse tools can use, giving you a nice reach as far as the tools that you're using. Okay, and that goes for and that what that suite of tools looks like will depend on the format that you choose. Okay, but Dremio helps in the optimization of Apache Iceberg tables. So if you have Apache Iceberg tables in any catalog, you can use Dremio to optimize them with the optimize command, which will run compaction to help take all those small files, make them fewer, bigger files for better read performance. Okay. Eventually, there's going to be snapshots that you don't need anymore. So with the vacuum command, you can expire older snapshots in your Iceberg tables that are connected to any Iceberg catalog, and clean up and do those cleanup operations where it's going to clean up all your unneeded data files, and on top of that, basically just clean up. Okay. And again, Dremio supports many catalogs. So again, you can use file system catalogs like S3 or ADLS or Google Blob Storage. Okay. You can use AWS Glue as a catalog. You can use Hive as a catalog. You can use again a HDFS system as a catalog, a Hadoop system. You can use Nessie as a catalog. You can just connect it to Dremio and have access to all these Iceberg tables. And that catalog support's constantly expanding. So, that reach is just going to keep growing. Okay, but that reach is already pretty wide with a wide variety of SQL support. So it's a very robust level of Iceberg support. And then Dremio is very, very optimized for reading Apache Iceberg tables in particular. Okay. Now, again, talking about that whole optimization story, not only does Dremio provide you a query engine that has a lot of support for working with Apache Iceberg tables, but it also has DremioArctic, okay, which is essentially a lakehouse management service, which in the sense that it's providing you that management. Okay, so when it comes to the different formats, okay, and I'll talk a little bit more about that with the other formats, but generally, like, you need some sort of service that's going to manage your tables, because you can manage them yourself and run all these maintenance operations yourself, but that can get tricky to manage and automate and whatnot. So it'd be nice to have a service that just kind of takes care of that, and that's what DremioArctic's for. It's going to allow you to catalog your Iceberg tables, but not only can you just run optimize and vacuum commands like we mentioned before, but you're going to be able to automate that and a bunch of other things. So let's kind of go through, like, what does DremioArctic provide you? Essentially, it's a catalog. So it's going to allow you to take your Apache Iceberg tables, group them together, and take them not only to Dremio's query engine, but you can take them over to Presto, Trino, you can take them to Spark, Flink. It's based on projectnessie, an open source project that connects to several different engines. So basically, it provides you this catalog that's going to have these management services, but also provide you portability among many different tools. So it is Iceberg native. It's built with Iceberg in mind. Okay, so it allows you to catalog those Iceberg tables and make them useful by different tools. You can create multiple catalogs. So the great thing about the Dremioarctic service is it allows you to create multiple catalogs. You don't have to necessarily spin up a separate Nessie instance for any catalog you want. At the click of a button, you just have a new catalog. And this is great for like things like datamesh to handle those like cultural scaling issues as we discussed earlier, because I can just go create a catalog for my my product department, I go create a catalog for my engineering department, and ta-da, those tables are now grouped together and are portable. Okay, then you have access control. Okay, one of the things that are growing and going to continue expanding as part of this sort of Nessie project and the Dremioarctic service that's built on top of it is the ability to create portable access control. So imagine that you have a catalog, you define the way you can access that catalog, and then that can be honored by Spark, by Flink, by Presto, by Trino, so that you're only defining how that table can be accessed once, and anyone with the same, accessing it with the same security token, they're going to have those rules sort of honored. Okay, so you're creating so this catalog not only creates portability of data, but portability of security. And then you can also govern it. You can have a nice UI where you can kind of view all the commits to these tables. Okay, because it's not only basically, well, the Iceberg format tracks commits at the table level. The projectnessie catalog, which powers DremioArctic, captures commits at the catalog level, which enables auditability of your catalog as a whole, okay, along with some other features I'll mention in a moment. But again, also with DremioArctic, you have table optimization, where you can actually literally turn on a schedule for it to optimize your table and just say, hey, optimize the table every hour, every day, every week, every 5 minutes, whatever you want to do. Okay, and same thing with table cleanup. You can say, hey, you know what? Let's expire snapshots at the end of each week, each month, every day. You can set those rules and just set it and forget it, and allow those tables to be optimized for you. Okay, it's going to allow isolation. So here's where we start getting to the nice things about that commit. Now, being able to capture commits at the catalog level allows you to do something very novel. It allows you to create branches of the catalog level commit history. So that means I can create a branch and isolate ingestion work on a branch. I could, create experimental branches and tag them. Okay, so it gives you a lot of those benefits of like Git at a catalog level, and all of this is accessible through SQL. So there's SQL language in Dremio and Spark, and in all the supported catalogs that allow you to express SQL to kind of work with this branching and merging and working with this sort of like this Git-like functionality. And on top of that, not only do you get these commits to isolate data, but you get version controls, which means you can do time travel and say, hey, I only want to query the state of the catalog at this point. So instead of having to specify the specific snapshot for each individual table, you can just say, hey, I want to scan the catalog at this point, and then all those tables will be automatically time traveled that are part of that query. You can roll back the entire catalog if there's a mistake over the weekend, then 100 tables got bad data in them. Instead of having to roll back each table individually, you can just roll back the whole catalog. Okay, very cool. Okay, and the last bit for like Iceberg, just a few other considerations is just that another angle in which Dremio makes use of Apache Iceberg is Apache Iceberg. Is the Dremio's data reflections, which are going to be the topic of next week's episode. Okay, so if you want to learn more about how that works and how you use them, please be here next week. But what they are is essentially they're creating a representation of your data. So think of it as like I always like to say like a materialized view on steroids, in the sense that it addresses many of the problems with materialized views, where you can only really use it for like one data set. You have to kind of query a separate namespace. You have to figure out how to keep it in sync with the underlying data. Dremio's reflections create essentially a materialization that's an Apache Iceberg table. So not only is it a physical representation, but it's going to get the benefit of all that Apache Iceberg metadata to be able to query that data more smartly. And then you can partition that reflection to even increase how fast you can query that reflection. So there's a lot of ways you can optimize that reflection, is my point. Okay. But it keeps it in sync. You don't actually have to query, so you can still query the original table and be completely unaware of the Dremio reflection, and the end user will still get the benefit of that reflection that was created. Okay, so it gives a lot of acceleration bang for your buck. Okay, so that's another cool aspect of how Dremio leverages Apache Iceberg. Okay, now remember I mentioned there's this whole world of managing tables. Okay, so basically in the world of Apache Iceberg, okay, the format itself doesn't provide you necessarily tools for that. Instead, it wants that to be left to the market. So basically right now in the marketplace, you have DremioArctic using that Nessie catalog that can provide you table optimization. And then you also have Tabular, which uses a REST-based catalog, which is the REST catalog spec in the Apache Iceberg spec, to provide you with that catalog, another option, which also provides automatic table optimization and other features. And that can also be used with Dremio. Okay, so in the Tabular UI, what you can do if you're using Tabular is you can sync a table to your AWS Glue catalog, and then you would connect your AWS Glue catalog to Dremio, and Dremio can then scan those tables in a read-only fashion. Okay, again, Dremio's catalog support is constantly expanding, so in the future, there likely will be full support for being able to connect that tabular catalog directly. But in the meantime, again, you can always just sync those tables with AWS Glue and then read them here in Dremio. So that way, if you need them to fuel a BI dashboard or make them available part for ad hoc analytics or in the particular data product, you can do that. So you have different options. Dremio is again an open platform. We want you to be able to, while we provide you tools, so that way you can work with Dremio to fill most of your data lakehouse needs. Okay, whatever you choose to use, there's a place for Dremio in your data stack. Okay, now what if you're using Delta Lake? Okay, Delta Lake can be read by Dremio. So Delta Lake tables, more than likely, if you're using Delta Lake, you're probably a Databricks user. So a lot of your writing to Delta Lake is probably going to be done over there on the Databricks platform. Okay, but you know, you have BI dashboards. Okay, and you want really nice, crisp BI dashboards, and this is going to be a place where Dremio can really provide you a lot of benefit to when you're using those Delta Lake tables. Okay, so you can connect the S3 bucket or whatever cloud storage that you have your Databricks Delta Lake tables stored in, and Dremio can read those Delta Lake tables, and then you can use reflections to accelerate them to create sub-second BI dashboards from your Delta Lake tables. Okay, the support for Delta Lake is always continuing to increase on Dremio. Will continue to expand. But bottom line is, if you have Delta Lake tables, we can read them. And the cool thing about Dremio is you can connect all sorts of things. You can connect you can connect to your Snowflake. So if you have Delta Lake tables written by Databricks, but you also have some tables that you wrote on Snowflake, you can connect it all to Dremio and actually join that data, curate views on that data, okay, to make it accessible to your end users without having to jump through any hoops and making those two platforms work together. So something to keep in mind, okay? But bottom line is Dremio is a place where you can harmonize your disparate data sources, okay? Okay, now officially, Hudi is not supported by Dremio in the sense that Dremio doesn't have any official read support for Hudi. Okay, but if you're using Dremio software, so that means you're using the on-prem version of Dremio software, there are unofficial jars out there that you can drop in your install that will give you the ability to read Hudi tables on your Dremio install. Okay, they're not officially supported by Dremio. Okay, so basically you'd have to kind of deal with any bugs, but those do exist if that's something you want to do. But there's another option. Okay, chances are, again, goes back to that whole optimization story. So again, if you're using Delta Lake, chances are you're using Databricks, so you're probably using Databricks to do a lot of your optimization of your tables. If you're using Iceberg, you have options like DremioArctic and Tabular. Okay, if you're using Hudi, your main option for table optimization is going to be OneHouse, which is there to kind of this is a little bit more like how Hudi works. Okay, is that the way Hudi works is that Hudi is unique from the other formats is that it actually not only is a format, but it also has this built-in service called the Delta Streamer. Okay, and the Delta Streamer is sort of this process that you can run. So as you ingest data into Hudi format, it's going to run things like compaction and clustering and things like that for you on your data. Okay, now if you were just using Hudi out of the box and implementing it yourself, you would have to host this Delta Streamer, maintain the deployment of this Delta Streamer and whatnot. So essentially what OneHouse does is going to is giving you a platform that kind of provides that for you along with other features. One of the cool innovations they have is this feature called One Table. This allows you to take any Hudi files, any Hudi tables that you've ingested and actually sort of externally mirror them out in the metadata of a different table. So you could externally mirror them as like Delta Lake table, as Iceberg tables, and sync them, in different ways. So there is already a feature on Hudi that allows you to take on OneHouse, allows you to take those Hudi tables, mirror them out as Apache Iceberg metadata in an AWS Glue catalog. So essentially what you could do is if you're using Hudi and you want to use Dremio, you could then, again, using that one table feature, take those Hudi tables, make them available as Iceberg tables in an AWS Glue catalog. Then Dremio can query them, help you get those, nice crisp BI dashboards, or, join them with other formats, provide data for ad hoc analytics or building data applications, all those kinds of use cases. So bottom line is, again, if you're using Hudi, it doesn't, as I said before, Dremio is an open platform. There is a way for Dremio to be part of your data stack, provide you the benefits that Dremio provides. Okay, but hopefully this kind of helped you see the different ways that different table formats can work together. So again, Apache Iceberg is going to be where Dremio has the most robust support. But again, if you are using Delta Lake or you're using Hudi, there is a story with Dremio and ways for you to be able to use those tables with Dremio, depending on sort of like what you're using and what your use cases are. At the end of the day, my recommendation always is if you see the value in Dremio, and again, if you haven't tried out Dremio, head over to dremio.com and try out Test Drive. Okay, so you can see what this platform is and see it in action. But best thing to do is like sit down with some Dremio solutions architects. Let's explore what your use cases are to see if and how Dremio can best fit in your architecture to save you money, increase performance, make life easier for your end users. Because again, Dremio is the easy, open, and fast Lakehouse platform, and we would love to make your Lakehouse easy, open, and fast. So my name is Alex Merced, again, here at another episode of Gnarly Data Waves. We're going to open it up to Q&A, and I want to answer your questions as best I can. But hopefully you guys enjoyed this presentation, give you a little bit more understanding of the space, and you walked away with something valuable. Again, join us next week where we're going to be taking a deep dive into Dremio, getting started with Dremio reflections. I'll see you there. Hey everybody. Okay, let's talk about answering questions. Okay, so again, if you have any questions, put them in the Q&A box. I got 2 questions ready to go, so I'm going to start answering them. And again, thank you all for sticking around through the entire presentation. But first, we have a question from Marcus. Can you explain with an example what happens when you store a transactional table in an Iceberg format? Does Iceberg read the table and create metadata tables? Okay, so essentially what would happen? Okay, so essentially what would happen is that you have your engines. You might be using like a Dremio, a Spark. So first, the engine's going to do its job of, like, let's say we're writing data. They're going to write the new data files based on the query, and they are going to take a look at the existing metadata for the table first to determine like how is this table partitioned, what is the schema, so that way it knows that information for how to write those Parquet files. So then it writes all the Parquet files with the appropriate partitioning, appropriate row group sizes, everything based on the settings of the table that they could get from the metadata. So once the files are written, the next step is then that's when the Apache Iceberg writers kick in. So basically they would pull from the Iceberg library, which has writers for writing the manifest files, the manifest lists, and writing the metadata.json. So first you do is you take that list of new Parquet files and pass it to, for like a particular partition, and you'd pass it to the manifest writer, and it would write a manifest file. So it would just read all those Parquet files, take a look at the stats in those Parquet files, in the Parquet footers, and use that to generate all the file level stats for each file being added to that manifest. Then those manifests, you would then pass the essentially, like, think of it in a code way, you would pass like the array of manifests to the manifest list reader, which would then create the snapshot metadata and write that Avro file that represents a snapshot. And then you would take that snapshot and pass it to the metadata.json writer, which would then take that along with any updates to the table, use that to kind of write the newest metadata.json, and then also update the catalog that's connected. So essentially, like, that would sort of be the right path. It starts sort of from the files and works its way up. But because the catalog, the reason why this can be done with asset guarantees is because any concurrent reads are going to the catalog, and the catalog is always going to point them to the existing metadata.json for the previously completed write. So this write that's kind of going on at the time isn't going to be read, and none of those files are going to be touched. There's no chance that read is going to be affected by that ongoing write. When that write's completed, it then updates that catalog mechanism saying, okay, hey, here's the newest metadata.json. And then going forward, any reads would read that new metadata.json and would be exposed to the new snapshot. And that's how it's able to kind of keep it in that sort of transactional format. Now, as far as trying to do like transactions on like multiple tables, that's where you'd want like something like the projectnessie catalog or dremioarctic, because there you can isolate transactions on multiple tables on a branch and then merge them in simultaneously. Right now, they are working on a spec for Apache Iceberg for multi-table transactions. It doesn't. How they're going to implement it, we'll see. But that's coming. But right now, you can do that now with a Nessie catalog. That would be sort of the way to do it right now. Okay, so that's the first question. But again, basically, the actual like writing of the Parquet files would be like that engine's chosen way of writing Parquet files, and then you would pass those Parquet files to the different writers for the metadata that are part of the Iceberg libraries that each engine will use to then write those layers of metadata. Okay, which that's all written in Java, but the Python implementation is slowly, like the PyIceberg is being built out, and then and so forth. Okay, next question. Often the best technology fails to win in the marketplace. Okay, I hear some I hear some, imagining of beta versus VHS. But hey, you don't use any of those now, right? How does Iceberg plan to counter all the industry momentum towards Delta Lake? One, I would question the premise that all the industry momentum is towards Delta Lake. I do think there is industry momentum, especially after the Fabric announcement. There is definitely momentum towards Delta Lake, but there's also a lot of momentum towards Iceberg. And then, I would say like each format, even when you don't hear about them daily, has been building out their imprint of people who are using them in production. Okay, so all three formats are being used heavily in production by different companies, particularly like, think Fortune 500 companies, because they're the ones who are going to have the big data use cases that really benefit from these formats the most. But I think what you're starting to see now is that each project is implementing more and more tools to help convert between the formats. So like Iceberg just came out with a Delta to Iceberg converter, a Hudi to Iceberg converters in the works. Hudi, we mentioned the one table thing that allows you to just kind of convert the metadata without actually having to convert the table. Delta Lake has converters into Delta Lake. So everyone's going to, all projects are going to make it easier and easier to switch. Eventually, the friction between switching between different formats for different use cases, the friction is going to be a lot less, and again, when you convert, you're not necessarily rewriting data files. A lot of times you're just rewriting metadata. So those conversions become a lot less impactful than rewriting a whole table. So that might reduce some of the friction. And I wouldn't be surprised if someday someone comes up with a whole separate open source project with just sort of a universal reader type tool where that wouldn't matter, where it just like allows you to read all three formats or something like that. That would be pretty cool. But as far as like, if we imagine them as like three purely competing forces, one, you do have a lot of people who have gotten behind Iceberg. I mean, when you think of like the Dremios, the Trinos, the Snowflakes, who have built robust Iceberg support. And the reason is partly because it's an open project, okay, in the sense that the people who are necessarily like writing Iceberg, they come from many different companies, and then so like, why does that matter? Does that make it better or worse? Like, the diversity of who the people writing the code are doesn't necessarily affect the quality of the project, but it does affect sort of like the longevity of the project in a sense. So, and again, here I'm talking about the core actual table libraries. So, for example, we go to Delta Lake, the core sort of Delta Lake format is pretty much primarily steered by Databricks, which again doesn't necessarily mean anything when it comes to is it a good project or not. And then a lot of the like tangential libraries like Delta RS and a lot of these other libraries have more sort of more diverse collaboration. But when you have a situation like what's going on right now, and this is my personal opinion for this next piece, when you think about what's going on with like Fabric, this kind of creates an interesting sort of dichotomy, because you have Microsoft, who's now creating a lot of support at the moment for Delta Lake, okay, which kind of creates sort of this sort of competition between sort of like the Databricks platform and a lot of the inbuilt platforms on Microsoft. What does that lead to sort of the decision making and the steering of the project going forward? What kind of influences might that create? Like, do we add X feature to the Photon engine? which doesn't have sort of an open source sort of equivalent. That's one of the Databricks engines. Or is it something that's added to some other aspect of the platform, like the Unity catalog, versus adding it to the open source format? So that way, like it creates some interesting like distinctions on like what the decisions will be made. I don't know. Like we'll see. But I think there's gonna be a strong place for all three formats going into the future. I don't think there's gonna be like, oh, this is the format, because there's gonna be platforms that support different formats that have different use cases, and people are gonna have different data that needs different use cases, and you're gonna want to use the format that's best for you. I think the friction between the three of them will become easier and less so over the time. So I'm not as worried about it, but I mean, if your concern is making sure that you're not stuck with a big price tag and have as many tools available to you as possible, Iceberg seems to have sort of like the widest sort of like read-write support across different tools at the moment. If your primarily concern is like, okay, hey, I'm using like Databricks and I want to have like the best experience on Databricks possible, then Delta Lake makes a lot of sense. If you're using, Microsoft and you're using Databricks, then, taking advantage of Fabric and all that stuff makes a lot of sense. If you're doing a lot of streaming and you like the streaming experience and you're a customer of like OneHouse, then it makes a lot of sense then to use Hudi. It depends on what your use case is, okay? But regardless of what format you're using, you probably have some, different use cases where Dremio can help you out in querying those tables. But I think, there's a plenty of things you can say to in each format. If you were to put like little wins in their column, as a format, they exist, and it's pretty exciting to see where this is going on. It's a really exciting space, and overall, it's been really exciting learning about all three formats and how they're used and their feature expansions and sort of like the way their projects are built up. Because like Iceberg, everything's kind of like in one repo, but again, we mentioned like how Delta has like other perpendicular projects, so like you have the Delta RS project, but they're all separate repositories. I think Hudi, everything is for the most part in one repository, and sort of like the details of that. Okay. So that's that question. How does Dremio operate in the context of encryption and data governance, especially in the multi-tenant environment with a variety of customer keys and access grant levels? Dremio has some pretty robust encryption encryption support. Now, as far as like getting to sort of the granular level that I think this question is trying to get at, I think that's going to be a conversation better suited for a Dremio solutions architect who probably implements these kinds of systems and these kind of situations for customers on a daily basis. As far as like figuring out what the right encryption for that customer is and sort of making sure that all that is set up in the most secure way possible. We're more than glad to get you in touch with sit down with a solutions architect to figure out those details to make sure that you get answers that are specific to your applicable use case. But Dremio does definitely have lots of features and a lot of incorporation with lots of tools like Apache Ranger, as far as like when we talk about access controls and a lot of other things depending on your particular use case. Okay, does Dremio integrate with open source metadata management gear project? That I don't know. I mean, generally, like if you're using Dremio software, so again, that's like the on-prem version of Dremio, there's all sorts of different connectors and customizations out there that you can use to incorporate all sorts of different tools. If we're talking about the cloud SaaS, then that's a little bit more like, okay, there's available connectors and these are the things you can use. But that I wouldn't, I'm not 100, I wouldn't be able to give you an answer. I'm pretty sure that's not supported on cloud. I don't remember seeing that come up in conversations in cloud. As far as is there unofficial connectors in the Dremio software world, I'm unaware. This is for the metadata management system, the Igaria project. But something we can always sit down and figure out with if it's part of your data stack and you have a Dremio use case, we can always figure out sort of what's the best way to kind of thread that needle. Okay, let me mark that one as live. Answered. Okay, how does one keep themselves up to date on capabilities of each table formats? Difficult. Iceberg being more open source and community driven, while Delta Lake, I mean, bottom line is like none of these formats are going to keep their features secrets. Like the Iceberg community, Databricks, and the Delta Lake community, they're all very eager to announce anytime there's something new and excited. So generally finding out about what's new and available to you, it's not hard. It's not hard, especially if you add a lot of people on LinkedIn. I would say like find out who are those people who love to talk about these things and add them. So like you want to hear about the latest and greatest stuff, when it comes to Delta Lake, add someone like Denny Lee. If you want to hear about like Iceberg and the data lakehouse space in general, like add someone like me and my counterpart Dipankar Mazumdar here at Dremio, here in developer advocacy, where just our job is to kind of be up to date on the newest things and talk about those new things, so that way we can do the work for you. But I mean, things I found useful is things like Google Alerts, following the right people on Twitter and on LinkedIn, just basically getting a nice list of people in the data community, so that way you're constantly like, and just following sort of all the companies, so that way you hear their announcements. And then also, following the projects on GitHub, so that way you get those announcements when there's like different commits and different pull requests and issues that you can go read up on. Again, there's only so much time in the day. Like for me, it's what I do. So but yeah, that's that. Okay, where can one test drive all three in one environment? As far as test driving all three in one environment, Spark is going to be your best bet for an easy place to test all three. What I would do is I would read my blog on converting Delta Lake to Iceberg, because there at least I set up Spark for Iceberg and Delta Lake, so you get to try out Delta Lake and see how and Iceberg in one blog post and see what the configurations are. And then literally, if you just go to the Hudi, you can documentation, you can see the Spark settings for that pretty quickly. And try that out. Maybe at some point I'll put out a blog where I just kind of walk through all three in Spark. I'll just put that in the back of my mind as something to do. Okay, answered. Is there anything of interest for domains with structure but not exactly general purpose formats? BAM, VCF. Oh, VCF, that brings me back. Before I was at Dremio, I used to do like, or one of the things I've done before pre-Dremio is I used to do some freelance work, and I actually created like this whole application for like reading VCF files. It never was released, but it was like a thing I was doing for a client, and so I got really intimate with VCF files. But right now, as far as like special file support for Dremio, there is some, and I think again there's sort of unofficial jars. I would sit down with a solutions architect, because sometimes we do have sometimes of special solutions for special situations. So again, depending on the use case, depending on sort of what is sort of like the best way to get you the right performance and get you the least friction to get from point A to point B, our solutions architects can really kind of figure out what that story looks like. Cool. Can Dremio work with Databricks? Well, that's an interesting announcement. So recently, Databricks announced that the Unity catalog, which is sort of their internal catalog, so think of kind of like what DremioArctic is to Dremio, but different. There's like different use cases. Has like a Hive API. So theoretically, Dremio supports Hive. So if you're using Dremio software, Hive is a potential connection. So theoretically, it should be able to connect to anything that has the Hive API. So theoretically, yes. I haven't tested this. Kind of like anyone who gets like, it's in the same way like that, Tabular and OneHouse can sync their tables to Glue, and that makes them usable in Dremio. Theoretically, if Unity Catalog supports the Hive API, that could make it usable in Dremio. I personally not have tried that out yet to confirm that is the case, but I don't see why it wouldn't if it's following the API, the open source Hive API. Okay. Comment only. If I was answering the question about market momentum, I would refer the Dremio partnership page. Okay, yeah, that's a great answer. Okay, read the Dremio partnership page, because that way you can get sort of like the official sort of like Dremio's perspective. Again, here I'm just kind of speaking extemporaneously. A lot of this is just sort of like my thoughts on the matter, just from just immersing myself. Does Dremio have a data lineage service? Now, here's the great thing about Dremio. Like, data lineage is built into Dremio. So basically, any source you connect, as you create views on that data source, which you can end up creating several layers of views between you and your end users. The great thing is that what happens is that whole lineage of how all those views get derived are totally visible and totally auditable. So you can see, okay, hey, this view was created based on these views, which were created based on these sources by this user with these changes, and you can kind of see how these different data sets evolved. This makes it really useful, especially for like ELT patterns, so export, load, transfer, where basically you're loading the raw data sets right into Dremio. So essentially all the transformations are happening through views in Dremio. So you're seeing the full sort of transformation lineage right there through the Dremio UI, which is pretty cool. Again, ETL works fine too. It's just like the lineage captures sort of like the transformations from within Dremio. So it won't capture any transformations from that happen prior to the source. So for example, if I were to make a bunch of transformations before loading the Parquet data into S3, and then I connect my S3 to Dremio, and then we make further transformations, I'll have a lineage of all the transformations past S3, but not previous from within Dremio, just to understand how that lineage view works. But that is there. It just adds another layer of the transparency you have in Dremio over your data, along with the wiki, so you can document the data, the semantic layer, so you can organize your data. So again, whatever your data is, you can make it really usable from Dremio. Now would I say, like, is there a preference between ETL, ELT? No, I mean, Dremio, part of us being sort of the open platform is we want to try to facilitate the patterns that, like, your workflows, the way you like to work them. So like our semantic layer, basically how everything works was made to be flexible, so that way when you use Dremio, it enhances your existing workflows, makes them easier and faster, but doesn't force you to have to relearn sort of new patterns just because you adopted this new tool. Because that's always one of the frictions you have when you adopt a lot of tools, and say, well, our tool will give you these benefits, but you're going to have to, like, now change the way you do things in X, Y, or Z way. Dremio really tries to be something that sort of like is a progressive enhancement. Depending on what patterns you do, we do have like recommendations, like, like far as like medallion architectures, depending on whether you choose ETL or ELT. But far as which one should you do, is everyone's use case is different, everyone's considerations are different, and we want to make sure that we have a platform that's moldable to what you need. It's a platform for data lakehouses, not just any specific type of data lakehouse. So that would sort of be my answer there. I think that's pretty much all these questions. So let me mark these as all done. The slide deck will be available when this is posted. So this will be available with all previous episodes over at dremio.com/gnarly-data-waves. And then if you sign up for this, you'll get an email to that link. And we also post this on YouTube and on Spotify, so to rewatch. So that'll all be within 48 hours, just because there's some prep work that gets done with the recording after we're done. But this will all be available. I'm on LinkedIn, so feel free to reach out anytime. Yep, there you go. That's the URL, dremio.com/gnarly-data-waves. You can find all the previous episodes, transcripts, slides, everything. There's a lot of great content we've had in the past. So if you haven't gone and seen those episodes, do check them out. And we have many more coming up. Make sure to be here next week when we'll be talking about data reflections. But until then, I'll see you guys there. Thank you very much for sticking around today. It's been a fun one. And hopefully you guys got a lot of value out of this. And either way, just keep data laking and accessing that data. I'll see you all later.